Now we're jumping ahead a few chapters to talk about a group of shapes called the conics. The conics is going to include shapes like parabolas, circles, ellipses, and hyperbolas. Hopefully a lot of this material will feel vaguely familiar, at least from your Algebra 2 classes. Now, there's a lot of information on this slide, and I'm going to refer back to it. I'm going to jump back and forth on the examples just to help you connect this information. So to start off, the parabola, the definition of it, it's the set of points that are an equal distance from a point to a line. So if you drew a line and a point somewhere, then you can imagine a dot out here, for example, that's about an equal distance from the line and to the point, and another dot around here, and another dot around here. So what happens is you end up with a big set of points that create the shape of a parabola, just like this. Now, getting into the formulas you actually see here, I do need to point out the importance of there being two different columns. So sometimes you'll be using the information in the left column, sometimes you'll be using the information on the right, and that will be mostly determined by whether you see either an x squared in the formula or a y squared in the formula. So the first thing you should be checking is, will this parabola have an x squared or a y squared? Or even if you're doing it graphically, you'll be paying attention to, is the opening going up or down? So is it a parabola that looks like this or this, compared to a parabola that's going left or right, in which case graphically you would be using the formulas on the right-hand side here. So start off by identifying x squared or y squared in your formula. Next, you're going to be looking for the h and the k values. Now, something very handy to note about the h and the k's, it's that h is always paired with your x value. So h and x always go together, no matter which parabola you have. And then k and y will always be paired together, no matter which parabola you have. So the first thing you would be checking is to try and label what is h and what is k. Make sure you take into account the fact that it's a minus symbol on these, which means that when you were writing down your coordinate, you'll need to change the sign of the number. So if you see x minus 3, then you would write a positive 3 for the vertex. Same thing with the k coordinate. If it says y minus 8, then you'd be writing a positive 8. So one of the things I like to do when I first start with a parabola equation is go through and say h equals blank, k equals blank, and then also this p-value, which we'll get to in a second. And then once you label those three, it's very easy to just fill them in to the appropriate formulas here. So that's filling out the vertex. It's the same idea for either of the columns, but I'm going to be focusing just on the ones on the left because the stuff on the right is basically the same. It's just which value do you add your p's to, for example. So next is the focus. It looks like a lot of numbers, but it's actually just the same thing as the vertex. You have h comma k, so start with that exact same number. But in this case, you're going to add something to that y coordinate. You're going to add the number p. Now be careful about the fact that in your original equation, what you have is actually 4 times p. So for example, if you see a coefficient of 12 and then parentheses y minus something, you're going to take that 12 number and divide it by 4 to figure out what p equals. And that's what you would be adding to your k coordinate. So start with a vertex, add p to the y value or the k coordinate. And then use that same number, whatever p was. Then you're going to write the directrix, which is the line that the graph kind of avoids. It's like it goes away from it. Well, for the directrix, make sure you do include y equals the number, because if you don't write y equals, then you haven't defined the equation of a line. If you just say 7 for an answer, you will be getting points off for stating the directrix. So it's very important that you write y equals, or in this case, that you write x equals, and whatever the number is. So again, start with whatever your k value should be, and then subtract the p number. And the last piece here is the focal width. This is the term that kind of describes how wide is the opening. So if it's a small number, then it must be a very narrow parabola. And then if it's a large value for p, then it would be a very wide opening for your parabola. So the 4p, which happens to coincidentally be exactly what you see written out front, 4 times p, you just need to take the absolute value of that number, and that will be your focal width. You don't need to have an x equals or a y equals on this. Now, I did try to give you guys some hints, some tips down here at the bottom, just to help you make sense of what you're doing from labeling out these values and determining which equation you have. So what I like to do is focus on either which one has the x squared or has y to the first power. If you have y to the first power, then you're going to be adding and subtracting the p number from the y coordinate. So focus on what's being raised to the first power. If it's y to the first power, add and subtract p from that. And vice versa. If you have x to the first power, not an x squared, but an x to the first power in your equation, then you're going to be adding and subtracting that p value from your x coordinate. So whatever is to the first power, that's what gets the p number added and subtracted for determining your focus and your directrix. So next we'll look at some examples similar to what you'll have in your assignments. Now this is an example that seems to be missing a lot of parts because I'm trying to start you off with a very basic one that doesn't have some of the strange numbers for Vertex and Directrix, for example. Now one thing I should point out is right off the bat, we should not have a number being multiplied by the x squared term. Whatever is to the second power should not have a coefficient. The coefficient goes on the other part. So if you look at this, I see an x squared, that means I need to get rid of anything out front of it and move it to the opposite side to make it match. So my first step here is going to be to multiply both sides of the equation by a -2, which means I will instead have x squared equals -2y. Now something else I will point out here is we seem to be missing numbers that are either added or subtracted from our equation. So if it helps, let me just show you that means what's happening is we have x minus 0 squared equals -2, and then y minus 0. So what's happening in this case, since we don't see numbers being added or subtracted, that just means our h and our k values are 0. Writing it this way, it makes it a lot easier to see that that's what's happening. So I'm going to start off and say that in this particular example, h equals 0 and k equals 0. And then the other important number for us to identify is the p-value, which is based on the coefficient. So again, let me show you from the rules. So 4p is the number that you see being multiplied out front. So make sure you identify that 4p is equal to -2. If you solve this for p, then p is equal to -1/2. So I strongly encourage that you guys just take a moment to go through and list what h, k, and p equal. And then when you're going through and filling in all the other information, the vertex, focus, directrix, focal width, all that fun stuff, it'll be very easy for you to just plug in the numbers and compute. So the first thing they ask us for is the vertex. Just to show you again, our vertex is h comma k. So now on the example, I can say vertex h is 0, k is 0, so 0, comma 0. Next, we're going to identify the focus, so I'll flip back to the formula. Here you can see that in our case, since we have an x squared parabola, it's going to be h comma k plus p. So our focus is h comma k plus p. Now do always simplify your values. In this case, instead of writing 0 comma 0 plus -1/2, I would just write that as 0 comma -1/2. Next, we need the directrix. So again, we'll compare that to the formulas on the other slide. You can see here that our directrix will be y equals, you have to include that part, k minus p. Y equals k minus p. So for our example, y equals k minus p. Instead of writing 0 minus -1/2 though, double negatives cancel, so I'm actually just going to write y equals +1/2. If you don't have the y equals, then you haven't defined the equation of a line. This is a horizontal line at a height of 1/2. And our last piece here is the focal width. I'm just going to abbreviate that as FW. So our focal width is the last piece we want to look at on the other slide. So you'll notice you just want to have those formulas handy and then keep looking back and forth at them once you've identified h, k, and p. So your focal width is to take that 4p value, the coefficient that's in front of the first power variable, and make sure you take the absolute value of it. That's all you have to do for the focal width. So we identified up here earlier that 4 times p equals -2, so I'm just going to take the absolute value of -2, which will flip the sign and make it equal to a +2. So again, please start off by getting the formula into the appropriate setup so that you have the coefficients and numbers on the right sides, and then just carefully list out what is h, k, and p, and then it's basically a matching game. Look at the rules and plug in the numbers accordingly, simplify where you can. So here we have our vertex, our focus, our directrix, and our focal width. Let's do another example. Now this one is already nicely in the form that we need. We have the y minus something squared equal to 4p x minus something. So on this one, we can actually go ahead and just start listing out our h, k, and p values. You'll also notice that for this one, we're using the column on the right-hand side because this time it's the y variable that's getting squared. So when I'm plugging in my h, k, and p values, I need to make sure that I'm using the ones on the right, and I base that on the fact that I have y squared in this equation instead of an x squared. So by labeling my values, h, it's always the number that's attached to the x. Don't forget to change the sign on it. So this one's going to be a -3. K is the number that's always attached to the y variable. Don't forget to change the sign on it. It's a +2. And then 4p is that coefficient. It should be next to the first power variable. It shouldn't be on the squared. It should be on the first power variable. So 4p in this case is equal to 4, which means that p is equal to 1, dividing both sides by 4. So now we have our 3 values, h, k, and p. That's what everything is going to be based on. So again, our vertex, this is always just h comma k. So I can plug in -3 comma 2. Then we have our focus. And so let me go back to the formulas to show you where this is coming from. Okay, our focus is going to be h plus p, comma, k. H plus p, comma, k. So for our example, h plus p, comma, k. This can be simplified, of course. So instead of leaving it that way, I know that -3 plus 1 is -2, and then the other number just stays as a 2. Okay, that was the focus. On to the directrix. The directrix for this is going to be x equals, make sure you include that x equals for the equation of a line, and then it's h minus p. So x equals h minus p, which is the same as x equals -4. So here we have our equation of a line simplified. And the last piece is the focal width. For both cases, this is just the absolute value of 4p. So the absolute value of 4 is still just 4. Don't change the sign on it. Remember, absolute value bars always make it a positive answer. It's not that absolute value bars switch the sign on everything. So since it already was positive, it stays positive. And those are the 4 different answers they ask us for. Again, the idea here, start off by just identifying h, k, and p, and then use your formulas to plug in appropriately. So the last thing I want to show you guys is about how to start applying this information to a graph. We've already talked about the fact that there are the parabolas that open up or down. Those are the ones that have an x squared in them. And there are the parabolas that open to the left or to the right. And these are the parabolas that have a y squared in them. Now, the way we distinguish between it being an up or down parabola is actually based on that 4p number. If that number is positive, greater than 0, then it's going to open up. So if you have a positive y, up. If you have a negative, which is a number less than 0, then it will be opening down. Same thing for the left and right parabolas. If that 4p value is positive, it will open to the right. And if it is negative, it will open to the left. So that's the way you'll distinguish between the graphs, or it's the information you would use to draw the graphs on your own. To kind of label those pieces of information we were finding a second ago, the focus is the point that's kind of inside the parabola. It's like it's being protected or shielded by it. You can see in every single case, the parabola is trying to surround it as if it was protecting it. The directrix is a line that your parabola avoids. It always goes away from the directrix. So wherever your directrix line is being drawn, your parabola should be going away from that point, away from that line. So now let's look at a quick example of how you might be asked to identify the correct graph. So in this one, you can see that for starters, we have a parabola that's opening to the left. So one of the first and best things you can do to correctly identify the graph is to say, well, then should it be an x squared or a y squared graph? And by looking at what we have on the previous slide, you can see that the left and right ones have y squareds in them, not x squareds. So I'm going to go back and just immediately cross out all of the ones that show x squared in the formula. Next, we just need to pay attention to the fact that it's opening to the left or to the right specifically. So within those two options, I showed you on this slide that for it to open to the left, the coefficient for p or p has to be a negative number. So out of the ones I see here, one of them has a negative number, the other one does not. So choice D would be the correct option in this case. The actual value there would just be determining how wide it is. So if there was another similar answer that was still going to the left, you could use the number out front to say, all right, well, is it 4 across at the focus? Or is it 8 across at the focus? Or is it 1/2 across at the focus? So wherever your focus point is, the focal width, based on that actual number there, that's going to tell you how wide the opening is. So that'll be all for the notes on this section. We'll continue our discussion of parabolas in the next bit of notes. Thank you.